So we are moving on in our 3.2 notes. We're moving on to part B of our notes. So last time in our notes, we talked about gradients of equations. And now we're just going to bring it in full circle and talk about the entire linear equation and what is going on with linear equations in all. How do we graph them? What is a y-intercept? How do we find y-intercepts? And then some IB questions that go with it. First of all, though, we talk a lot about solution sets. Realize that a line, any graph, is always an infinite number of points along that graph. So if you were to draw a graph on a coordinate plane, you have anything that looks, something like this. This just means it has infinite points that were all lined up along this graph. And so when we're trying to find solution sets or solution points to determine if this is a solution, what we're really asking does this point lie on this line? And how we find that out is we plug in these x and y values. This is x, this is y. We plug it into our equation. And if that equation still holds true, if it gives us a statement that is true, then they are solutions to the equation. So if we were to try this out, I would plug in positive 2 for y equals, I like to put a little question mark over the equal sign to remind myself that I don't know for sure that it's equal and I need to prove that it is equal or it's not. And then negative 2 times x, which is negative 2, and then minus 2. So then 2 equals question mark. Negative 2 times negative 2 is positive 4 minus 2. So that's 2 equals 2. Since that is true, this is a solution to the equation. Going ahead and trying with this one, I would like for you to go ahead and tell me whether or not this is true. Plugging in positive 1 for y equals question mark, negative 2 times negative 1 for x minus 2, 1 equals 2 minus 2. 1 does not equal 0, so this is not a solution. Go ahead and try again on problem number 3. We plug in 3 for y, 0 for x, and we get 3 equals negative 2. That is not true. So again, this is not a solution. So that is pretty much all that's going on with that. It's just something that pops up every once in a while on your questions of, is this point a solution to this equation, whether it's linear or not? And it's just as simple as plugging it into the equation and then seeing if it holds true. Okay, linear equations. Let's talk about it real quick. A linear equation is an equation that has just x, so a degree of 1. Which just looks like x. You can see it as mx plus b, ax plus b, or something like that. But a lot of times, in this case, your textbook calls it y equals ax plus b. It will only have one solution. The number of degrees that your equation has will always be an indicator of how many possible solutions there are. So quadratics can always have 2, but the highest degree is 2, which means that the most number of solutions that you can have is 2, whereas a cubic, which has a degree of 3, has the most 3 possible solutions in order for this to be true. Okay. A gradient is our slope. We spent a lot of time talking about it. It's your change in y over your change in x, delta y over delta x. We have a formula, y2 minus y1 over x2 minus x1. Remember, it doesn't matter which order you have it in as long as you're consistent. If you put the second point first, you need to make sure you do that both in top and bottom. Okay, y-intercept. Y-intercept is the point where the graph crosses the y-axis. The y-axis is this vertical one. The point where you cross it is going to be here, or here, or here, or here, right? It's always going to be on that line. And on that line, the truth is that your x value is 0, right? We haven't moved left or right at all. So if you're on the y-axis, your x value is 0. So that is always how we find the y-intercept, is set x equal to 0. That is a how-to right there. We also have different forms, and these different forms can help us in different situations, right? It's the key that unlocks a door given a certain amount of information. So the general form is a lot of times where we end a problem. A lot of times your questions, your IB questions will say like, find the equation of this linear relation, make sure to put it in general form. General form is ax plus by equals c. Sometimes it's also ax plus by plus c equals 0. Either of those are correct. You just need to make sure that a and b exist as integers. This like weird e means exists in, or is in the set of all integers, which means that they just need to be whole numbers. That's what we're looking for. Your gradient intercept form is also called your slope intercept form, and it has a slope and an intercept. This is your mx plus b. M is your slope and B is represents your y-intercept. Remember that your y-intercept is still a point. B is just the y value of your y-intercept. So your y-intercept would always be 0 and then that B value. M is your slope. Slope and intercept makes slope-intercept form. This is a really, really great form if you are trying to graph. Good for graphing. It's really nice because you can start at the y-intercept and then count up your slope and finish out the points and connect the dots. So general form is a typical end of a problem. Hey, put your answer in general form. That's typically when we use it. Your slope-intercept form is great for when we're graphing. Typically, you want to move it to this way if we want to graph, or if we want to solve for a system of equations and we want to isolate for one variable, we would isolate for y, typically. Point gradient or point slope form is when you have a point and a slope. This is great for when you're trying to make good for making equations. The form is y minus y1 equals m times x minus x1, where m again is your slope, x1 and y1 are points. Okay, so x1, y1 are a point that you can plug in, but you could also plug in 2 different points and solve for m this way. Notice the relationship between this and your slope formula. What if I wanted to solve for m? Well, I would divide out this whole piece and divide it over here, right? So it'd be y minus y1 divided by x minus x1, which is very similar because it is the exact same thing as your slope formula. This is really great if you're starting to make an equation. So if you're given a bunch of information and they say, hey, make the linear equation, a lot of times you'll use this as the first one to the first form of the linear equation in order to then find out more about what's going on. Your horizontal line is a line where all of your x values always stay the same. All of your y values always stay the same, right? So no matter what, x could be 5, x could be 10, no matter what, your y value will always stay the same. So that's why your horizontal line is always y equals a number. It could be y equals 3 or y equals 4. It'll be because that, no matter where you're trying to plot a point, x could be 12, this will still be 4. Negative 4, this would still be 4. So it's just, hey, y will always be that number, 4. Whereas a vertical line, your x value always stays the same. right? No matter what point you put on here, it's going to have the same x value no matter what. So we just say, hey, it's just always x equals this number. All right, a ton of information. Hopefully I'll recap. This was taught to you many times. If it's still something that you struggle with, definitely feel free to reach out or reach out to those additional resources to try and understand more about them. And we're going to spend class today talking about them, but more in an IB way.